So myself, Sumit, working as a senior application engineer for EDA, Pune branch. Okay. So today we are going to see a tool called as an IE3D. So probably everybody has heard the name as IE3D previously, but the name has been changed recently. So Mentor Graphics has acquired the product, and the name is been Hyperlynx 3D here. You know the antenna designing, how an antenna is designed. So for designing an antenna, like for a substrate-based antenna, for example, like you have seen your mobile devices. So in mobile devices, the antenna is basically constructed on the PCB itself. How exactly it is? So PCB is nothing but the FR4 material. Basically we called it as a substrate in case of IE3D. So basically your antenna is mounted on, or basically fabricated on that particular PCB, that is the substrate material. So as you might be knowing about IE3D, so IE3D has different programs for achieving this task. Like if you see, like this is mgrid. Mgrid is nothing but editor where we can create the antenna structures. For viewing the waveforms, we have pattern view, the module called as a pattern view. Modua is circuit simulator. Like if you have an S parameter data of some simulated antennas, I can connect passive elements like a resistor, capacitor for it, because it's not possible to connect them on board. So for simulation purpose, we got a Modua where I can connect the passive elements. IE3D library is just similar to mgrid, but it is more like in library fashion. It has some predefined structures in it, which would make my design much more easier to do, as well as it is with more parameters, so more control over my design. And the line gauge and line gauge is for what we can say waveguide simulation, and MD spice is for spice simulation. So we'll not go much in the tool itself. So we'll see a unique feature of IE3D is as like it is used not just for simulation purpose, but it can be used for an optimization purpose. Okay. So for that purpose, you should see a structure, one antenna, microstrip antenna. So everybody might be aware about microstrip antenna, how a microstrip antenna would looking. So this is the structure of a microstrip antenna. So it has a parameters such as length, width, and this is nothing but what you can see here. This is nothing but an inset feed. So controlling the depth of an inset, I can adjust the resonance of my antenna, and controlling the length of my antenna, I can adjust the by controlling the depth of an inset, I can adjust the what you can say impedance matching, and by controlling the length, I can adjust the resonance frequency of my antenna. So everybody knows about how an antenna operates basically. Antenna is nothing but a structure, metallic structure, which on excitation, proper voltage excitation, will emit energy in a targeted particular direction. Similarly, vice versa, it can also receive energy from some particular source also. So antenna is nothing but a transmitter as well as an emitter. So in this case, you'll see this antenna has got parameters just like width, length, and this is nothing but an inset feed. The port from where this is the inset feed from where you will excite your antenna. Okay, so this is been excited through that particular inset feed. So by controlling the depth, I can do the impedance matching, and by controlling the length of this antenna, I can achieve the resonance. So in this case, we are trying to design an antenna which is basically operating at 1.88 gigahertz. Okay, so I have done the calculations and found that these calculations, what you can see my screen, right? So in you'll see this. These are the calculations which are supposed to if I design my antenna using this calculation, it should operate close to 1.88 gigahertz. Okay. So what we'll do, we'll try to just construct this antenna by some more advanced features of IE3D for constructing this patch. So and we'll see the results, and if the results are not matched or not up to the expectation, we can use the unique feature of IE3D that is called an optimization, so that it can perfectly tune at 1.88 gigahertz. So as I said, this antenna is basically mounted on a PCB structure, and mgrid is a module of IE3D where we can construct our antenna. So what we'll do, we'll just go to mgrid. So basically, as I said, PCB is nothing but the substrate material. So every substrate material has got its properties. that is called as a permittivity and the thickness. The thickness is nothing but the width, thickness of that particular material, and permittivity is nothing substrate manufacturer for these properties. So the commonly available material in industry or in the market is FR4, the common PCB what we use, and it has got a property like it has got thickness of 31 mils and the permittivity close to 4.4. So what we'll do, whenever we just create a new structure, it will pop up a window where I can define the basic parameters of my design. So in this case, I'm just changing my unit from millimeter to mil. Mil is a common unit. So mil is a common unit for it. So we're defining the unit as a mil. So the next thing is we should do the machine frequency close to 2, and cells per wavelength we define it as a 15. You'll see you'll get this idea when we are doing the design, but you just remember these settings now. The next is this. You can see the two layers here. One is G and other one is D. G is nothing but the ground, because in this case it is an infinite ground, because we have not defined any boundary for the ground. It is an infinite ground. And the D, what you see, is a substrate layer. So as I said, for substrate we need to define the two properties. Z, as I said, it should be 31 mils, and the dielectric constant is 4.4. So we defined the two properties. One is Z top, that is the thickness of my substrate, and the other is dielectric constant 4.4. Click on OK. So we have defined the basic parameters which are required for my substrate, and also the layers which are necessary for our design. In our design we just require one layer, that is substrate, because it is not a stacking layer design, it's just only a one layer design. So click on OK. So you'll see a blank screen where we basically, this is the editor area where we will create our structure. So if you see the structure now, it is nothing but a rectangular patch which has an inset, that is the cut where which is fed through a inset feed line. So if you see the dimensions of this patch, the width is 1500 mils and the length is 1512 mils. So what we will do, first we will try to construct this rectangular patch. So IE3D has a feature or facility directly to enter the rectangular patch. So just click on this rectangular patch. So it will pop up a window where it will ask for the coordinate, that is x0, y0 means the patch would be placed at the center of my screen area, and the z coordinate is 31 because by default the substrate thickness what we have defined is 31 mils. So it will ask for the length. So just enter the length parameters. So the length in your case is 1512 mils and the width is 1500 mils. Okay, so we are constructing a rectangular patch with length 1512 and width 1500 at the center and with the thickness of 31 mils. So click on OK. So click on all after that. So you will see a rectangular patch has been created, but we want a cut here. We want a cut here with the depth, that is a D, nothing but the depth of that cut. So it is particularly 452 mils. So we want a cut of 452 mils and the width of that particular cut should be 115 mils. So what we will do, so this cut is particularly at this set of vertices. Okay, so in IE3D everything works on the vertices. Okay, so these are nothing but the two vertices of my rectangular where I want the cut, this one and this one. So what we will do, I'll just go to edit. So you can see the difference. Once I window it, you will see two corners which indicates that you have selected that particular set of vertices. So next is advanced edit. If you go to advanced edit option, there is option for cutting the polygons. Cut into polygon on edge. I want to cut a polygon on that particular edge. So it will ask for the depth and the width. So as we know, the depth of that particular is 452 mils and the width is, that is the S basically, it's 115 mils. Okay, so click on OK. You'll see a cut has been created here. Okay. The next thing is we want a feed line. We want to create this structure. We want to create this feed line. So if you see the length of that particular feed line is D plus F. That is this D 452 plus F 750, which comes to be 750 plus 452. So 1102. So that is particularly the length of that particular feed line. So we want to create this feed line on this particular edge. So what I will window these two vertices, and after that in advanced edit option there is option for continuing the straight path. If you go continue straight path, so it will ask for the patch length, which is 1102. Sorry, 1202, and the patch start width is 60 and the end width is also 60. How come 60? Because if you see the thickness here, it's nothing but a 60. So I define this patch line. Click on OK after that. So you see feed line has been created. Okay. The next is our structure is ready. You just save this structure with whatever name you want to give and the location where you want to keep it. So just save it somewhere in D drive with name unoptimized. Okay. So we have saved our geometry. The next thing is it won't act as an antenna unless and until it has been excited with our port. So we need to define a port. Port is nothing but the source from where we can excite our geometry. So we'll define a port for an edge group. If you go to port, there is an option for defining a port for edge group because this is an edge basically. You click on advanced extension is fine. You just window this edge. So port has been placed for it. So we have defined a port. So the antenna will be excited through this particular point. The next thing is what we need to define. We need to mesh our structure. The meshing is nothing but this is the whole structure. We need to mesh. Mesh means it will divide this whole structure in a smaller cells, and the results would be calculated on individual cells, and the final result would be the integration of a particular cell's results. So more fine you mesh your structure, more accurate would be your results. So what we'll do, we'll mesh this structure. So for meshing, you just go to process, so you will ask for meshing. So in meshing I will define some parameters. AEC layer I will make it as 1 and AEC ratio I will make it as 0.05 because we have done this because if you see the gap between the substrate feed line and the antenna is close to 30 mils. If you do the calculation, it comes out to be some close to 28 mil. So it will not fill that particular cavity. So we need to define a mesh which would be smaller than that. So I define an AEC ratio close to 0.05. Okay. So just click on OK. Continue. So it will show how exactly my antenna is being meshed. You see a smaller squares and rectangles. These are nothing but the individual elements which would be used for the simulation purpose. Okay. So the next task would be to simulate this structure. So if I go to process, simulate. So as we know, we have designed this antenna to be operated somewhere close to 1.88 gigahertz because I have done the calculations accordingly so that it should operate close to, if everything goes fine, it should operate close to 1.88 gigahertz. So we need to give a frequency in that particular ranges only. So like we have designed an antenna which is operating at 1.88 gigahertz and you are giving a frequency range of say 2 to 4 gigahertz. So you are not able to monitor the response of antenna at that particular frequency. So you should have a rough idea where my antenna is going to operate particularly. So I need to enter the frequencies. So in simulation window there is an option for like entering the simulations. So I will enter the values like I want to simulate this structure from 1.7 gigahertz to 2 gigahertz. because I know my antenna is operating close to 1.8 gigahertz. And it will ask for the number of frequency points, like how much frequency you want to simulate. So I'll say like I want to simulate this antenna for 151 frequencies. So click on OK. So as soon as I click on OK, all these frequencies it will be entered. So it will try to simulate the antenna for each and every frequencies, and it will plot the results for you. So IE3D has a smart engine called as AI that is adaptive IntelliFit. So what it will do, it will remove the redundancy in your simulation. Like the results of certain frequency points are similar. So it will not simulate the structure for all those frequencies. So it will select some random frequencies, and what it will do, it will try to reduce the simulation time. If you try to simulate it for 151 frequency points, it is not time consuming. So it has a smart simulation engine for it, which identifies those frequencies which are necessary only for simulation. Okay. So once it is done, again we want to define the graphs as for seeing the frequency response of my antenna or resonance of my antenna. I need to define a graph called as an S parameter chart. So there is option for defining graph in IE3D. So I'll just click on add graph, S parameters. Okay. Which parameter you want to monitor? Like I want to monitor a dB parameter for it. Click on OK. Again, I need to see the Z parameter chart for it. So click on Z1. Which plot you want, imaginary, real. So I want a magnitude plot for it. Click on OK. Also, I need to define a graph like say Smith chart for in this case. Okay, so I'll define. I want to see a Smith chart also. S11 is nothing but the port structure. It has only a single port, so it will show only S11. That is the parameters for it. Click on close, and after that you just simulate it. So it will do the simulation. So one frequency points. So you can see in the simulated circuit where the antenna resonates. Maximum power transfer, if you know transfer theorem, if you know, if there is a zero impedance, the antenna will transfer maximum power. So in this case, it has lowest impedance. So this is the operating point of an antenna. So if you check the frequency response of this antenna in dB, it is operating somewhere close to 1.87 with minus 5.7 dB. That is the gain of that antenna. So it is not operating close to 1.88 gigahertz, and the frequency response is also not so sharp. If you see the peak, inverted peak, it's not so sharp. So the next task here is our task is to design this antenna, to simulate this antenna to 1.88 gigahertz, exactly at 1.88 gigahertz. I want to resonate this antenna exactly close to 100. So in this case, the optimization feature of IE3D comes into the picture. So what we will do, so we have created already a structure here in IE3D. So this is all the structure. So as I said, if you control the depth of this antenna, the depth, the D parameter here, we can control the impedance matching. So impedance matching should be 0. Whenever the antenna resonates at that particular point, the impedance should be 0 or 50 ohms. So it should be 50 ohms. And the length, I need to vary the length and the depth of an antenna. So how an optimization in IE3D works, it will do, what it will do, it will sweep the length according to our definition, as well as it will sweep the depth also. So it will change the geometry dimensions, and it will find particular point where exactly my antenna is operating at close to, or 1.8, not close to, exactly at 1.88 gigahertz. So I need to define the variables for those particular two things. One is for length and one is for the depth. So how we can define it in IE3D? So what we need to do, if you go to edit, select vertices. So I need to change the length of an particular antenna. This is the length of my antenna. So I told you, I will window this these edges. You'll see the 4 vertices has been selected, 1, 2, 3, 4. So I can sweep this along x-axis to change the length of my antenna, right? So I can sweep the length. So sweep these vertices to change the length of an antenna. So what I will do, if I go to Optim, there is an option for variables for selected objects. So I will define as a new variable. You just define it as a new variable, and it will ask for the range. The tuning angle is 0 because basically we are sweeping the antenna on x-axis only, so the tuning angle has to be 0. As soon as I click on OK, it will show the, you see that the cursor is moving. It is asking me to define the lower bound for this particular antenna. So I just click on the left mouse, it will ask what lower value you want to define. So in this case I want to define it as a 100 mil. So it will sweep the antenna in the range of 100 mil in the negative direction and 100 mil in the positive direction. Okay, so we have defined one variable. So you need to define whenever you are defining the variables for sweeping, you should make sure that it should not violate the antenna geometry. Like in case we are going to define one more variable, so the limits of those variables should be in bound. It should not cross the bounds what we have defined for this particular variable. So continue without action. So we defined some variable for length. Similarly, I want to define a variable for the depth also. So what I will do, so again I will go to advanced edit, select polygon, select vertices. I will window this particular vertices because I want to change the depth. Now see, we cannot change only the length and the length or a depth. We have to change both the parameters simultaneously. So what I need to do, I need to map this particular parameter or a variable to my first declaration. So if I go to obtain variable for selected object, so there in this option vertices are mapped to new variable, but I don't want it mapped to a new variable. Instead of it should be mapped to variable 1. Okay, I'm mapping it to variable 1. So after that you just click on OK. Continue without actions. Okay, so we have defined a variable which is mapped to particular variable 1, and it is for the second sort of vertices. The next thing is I want to define the bounds for that particular variable also. So I go to Optim again, or basically you just select the vertices again, you window it, go to Optim, variables for selected objects again. So in this case I will define it as a new variable, and again the tuning angle would be 0 because we are sweeping it only along x-axis. And as soon as I click on OK, it will ask to define the boundaries for it. So in this case I'll just define it as a negative as a 200 mils and positive as a 200, positive 200 mils. So what we will do, so you'll see what exactly we have done. So if you go to display trends of all variables, it will show which variables we have been declared, like this is for length, or probably if you go to geometry tuning, it will show which variables we have defined. So if you go to variable slider, you can see the variables what we have defined. This is the first variable which basically controls the length of the patch, and this is the variable which generally controls the depth of the patch. So what IE3D will do, IE3D will change those parameters or this variable simultaneously and find exactly the point where my antenna is operating at 1.88 gigahertz. So okay, it will do some random simulations for it. So we need to define the process for it. So if you go to Optim, process, and there is option for optimization. Okay, so the next thing is we want our antenna to be operated at 1.88 gigahertz only. So what we will do, we will tell our simulator that you simulate the structure for only one frequency, that is 1.88, no other frequency I want. I want the structure to be simulated only for 1.88 gigahertz. Okay, and the next thing is I need to define the goal. So see, whenever the impedance matches, the real part of S11 the variable, and the imaginary part of S11 should be 0. Whenever the exactly impedance matches, the real as well as imaginary part of antenna becomes 0. So that we have to define here in the goals. In optimization definition, there is option for defining the goals. So I'll click on insert. It will pop up a window which will shows the frequency range. In this case, it's 1.88 gigahertz. It will ask which parameter you want, or basically the definition of that particular parameter. So in this case, I want real part of S. This is 1 and this is 1. Okay, because the only one port we have, so it will have only bus S11 and S11. So this is S11. An objective that it should be 0. Find a particular point where my real part of S11 should be 0. Click on OK. Similarly, I'll define one more goal for imaginary part. So I click on imaginary part S11. Similarly, it should be also equal to 0. Okay. So we have defined two goals here, that real part of imaginary S11 as well as the imaginary part of S11 should be 0. So what IE3D will do? It will sweep those ranges what we have given, and it will find a particular point where this condition is being met. So that point is nothing but the optimized antenna. That is the antenna which we are looking for. Okay. So click on OK. So what it will do? You will see that the screen is flashing number of times. So it is randomly simulating all those frequency. So it will do some permutation combinations and find particularly that point where antenna is close to 1.88 gigahertz. So this process is called as an optimization. You are not doing it manually, the tool is doing on its own. So it will run for some time. It will take some time. If you are defining more meshing frequency and you are defining some more variables, the simulation times will increase many folds. Also, one more feature of IE3D is that you can do this simulation or optimization in real time. That is called as the fast EM kit from IE3D, where I can manually slide those variable slides and see the graphs, or I can tune the graph. So automatically it will change the geometry as well as the graph. So I can fit on the geometry for that particular response. So it will take some time. The simulation in many cases can go up to 1 day also if you are doing more meshing frequency and more variables. So in this case we have declared only 2 variables, so it should not take more time here. So it will depend upon your processor also. If your processor is fast, probably the task will also be. So it's taking more time here. Meanwhile, it shows the information also, like how much RAM it has been utilized for which particular frequency it is being simulated in information window here. Okay, it is taking much more time. We'll stop here because I have already one optimized solution. What you are at the end of the simulation, what you'll get a new geometry which has been optimized. It will open a new window of mgrid which has a patch which is operating at 1.88 gigahertz. So what we'll do, I'll just open that patch after the optimization.
So I was asking for the address you send the CV, saying that what's the ID to get generated, then only it will be done. Yeah, I could not understand. You said I have already had a word with you.
Okay, we will just open that structure directly. So this is the optimized structure which is obtained once the simulation is being completed. So we need to re-simulate this design again. If you go to process, the same process what we had in previous also, just enter the frequencies like 1.7 to say 2 gigahertz and to simulate it. The number of frequency point is 151. Okay. Also, we are interested in seeing the current distribution and the radiation pattern, and also we want to see the response for particular frequency, that is 1.88. So make sure here check that particular frequency, so it will not, the simulator will not miss out those frequency, that particular frequency. It will simulate the structure from 1.88 again, and just check for the current distribution and the radiation pattern. You need to just select all and add it. Okay. So what it will do, it will simulate the structure, optimized structure, and it will check the response for 1.88 gigahertz. Probably the another simulation is just going, that's why it is not allowing me. Need to close it. Okay, just click on OK. So we need to add graph again. I want to see a graph for S parameters. Click on OK. I want it in a DB format. Click on OK. So this is the plot. Now, if you see the dip here, the dip is at exactly at 1.88 gigahertz, right? See, the dip is particularly exactly at 1.88 gigahertz. So our antenna is basically optimized to 1.88 gigahertz. So you can just save this antenna and we are ready for it for fabrication. So this is how an optimization of a feature of IE3D works. So basically the tool is smart enough to do the optimization on its own, but it cannot replace the designers, because it's the quality of a designer which the tool will never achieve, because the tool will do on it some certain sort of algorithms. So, but this is a quick way of if you don't have much time in doing the calculations, so you can always go for this particular process. So also, if you want to see the radiation pattern and all these things, so I want to see it for 7.88 gigahertz. Click on OK. So it will show the radiation pattern, as well as it will show the meshing also, how that particular antenna has been meshed. If you want to see a 3D graphs for it also, you can see. If you want to see the current distribution also, you can see how exactly that particular current is being distributed. You can animate it also. So whenever our source is being excited in the antenna, it will show how exactly the antenna structure is being excited, how the currents are flowing. Basically, if you see, the antenna radiates it from its edges. So whenever the excitation is there, the charges accumulate at the edges of an antenna. So this is how exactly optimization in IE3D works. So otherwise I can show you fast TM data also, where I can tune it manually and adjust the graphs. What we can expect from optimization. Okay, this is all about optimization in IE3D. So it will depend upon the structure. The more accurately we can optimize it in IE3D library, because IE3D library is more on parameterized fashion design. So I have better control over the parameters for optimization. So I can define multiple variables for optimization. In this case, we have defined only 2 variables, because it's some pretty easy structure, microstrip, which has only 2 parameters to control the visual resonance. One is for length and one is the insert depth. So this is how optimization works in IE3D. So any questions from audience? If you have any questions, kindly put it on the chat window. We open this session for the next 5 minutes, and just if you have any doubts or any question, just put it on the chat window. We will answer that. So request you, if you have any doubts or questions also. Yeah, so you can send the mails to the Sumit directly, and you can get it answered. And yeah, that's fine. So thank you, Sumit. This webinar will available offline at our YouTube channel by next week. For the next session, you need to log in with the link provided by the email.